So number 2 will be the compressive stress. Compressive what? Compressive stress. Now, the compressive stress is an equal and opposite push force that decrease or tends to decrease the length of the material. Now, if I have this way, this is my compressive force. Let me call here P, and here to be what? P. Now what happened? This force is trying to compress. When I mean compress, something that is trying to reduce the size of this material. So this one out here is my change in my L, right? I call it my L, and this one here means my L minus delta L, because it's trying to reduce the material. Are we good now? There's one thing you need to understand. As it's reducing the material, what happened? The cross-sectional area of the material increases. So compressive stress tends to what? Increase the cross-sectional area, the thickness of the material. While tensile stress tends to what? Reduce there's a reduction in size. Reduction area, yes. So there's a reduction area here, and there's an enlargement area here. Is that okay now? That is for that. So now we are moving forward. Number 3, we are having what we have is what we call shear stress. Shear stress. Now shear stress on its own. So this is an equal and opposite word, parallel force. Is that taken? Whose line of action are not the same. The line of action are not the same. Is that taken? Now what it means is this. If I have this material like this, alright? If I have this material like this, is that taken? And this is the length of the material, L. So if I shear the material at this axis here, X, what happened? This top one we want to topple over the other one, so we'll be having something like this. We'll be having something like this. So this is coming this way, and this is going this way. So this is A, this is B. This will be my A, and this will be my B. It's tending to what? To slide one body over another body. So it's shearing, right? So now, and also, what you need to understand here also is that the shear stress is given with the symbol tau, and that also gives me force over area. So shear stress is always acting tangential to what? To the plane. Is that taken? So let's proceed and see. Other types of stress that we have the thermal stress, that is as a result of what? Temperature change. When you constrict, like if I have a material this way, in terms of thermal stress, if I have a material this way, right, I fixed it to two endpoints, right? I fixed the material and I start heating it up. I start applying heat, right? This material we want to increase because heat brings about expansion. So when this material is trying to expand, this fixed axis will be restricting it. So as a result, there's a thermal stress. And what we also have, we call the torsional stress, and so on and so forth. So we'll move further and see how it goes. So we'll be talking about the next one, which is strain. Now we can say our strain is the measure. We're coming to strain now. The strain, which is given as a symbol epsilon. This is the symbol for strain, right? It's a Greek word. We say the strain is the measure of deformation produced in a member by a load. So the measure of deformation produced by a member on a load is called strain. Is that okay now? Now let's assume that I have this member this way that is fixed to this axis here. Are we good? If I apply a tensile stress, that's the force, what happens? This material will tend to what? Increase in size. So the actual length of the material is L, right? Now if the material increases, we'll call here to be what? Our delta L. So our strain is equal to what? The change in dimension over what? Original dimension, right? So this can either be, we'll put it this way by saying the L minus what? L naught all over what? L naught. If you recall, if you look at what we are doing this, so it will be the increase in length, the original length minus increase in length all over what? The increase in length. Is that taken out? So now let's proceed. So the strain doesn't have any unit. Is that taken out? The strain has no unit. So we should understand that we also have different types of strain also, right? One of the strain that we also have the shear strain, we have the compressive strain, and we have the tensile strain. In terms of the shear strain, if you recall, in this case here, that will have tensile force here, tensile stress. So if I want to have my tensile strain, it will be also delta L over what? Original length. But in this case now, it will be increase in length over what? Original length. Why? Then compressive strain, it will be what? Also delta L over what? Original length here. But in this case here now, it will be what? Decrease in length over what? Original length.